Yeah. I think your point about kind of desiring that you had worked for a contractor is a super important point, because that was one of my biggest hurdles, if you will, or learning curves when I started structural engineering, was still having a lack of commercial construction experience, where you can design drawings, or you can draw drawings, draft drawings, or however you do it all day long. But then there's a lack of connection with, is this actually buildable? And is what I'm drawing very difficult to, execute on the job site? So having the experience, like you said, of being out on an active job site for a summer, especially, but even just, getting out on active job sites as often as you can, whether it's organized building tours in your area or something like that. I'm a big proponent of that, because that connection, that feedback loop of, this is what I drew, this is what I designed, this is what it actually looks like in the field, and it's really difficult to implement that, or it went together really well, and here's why. That feedback loop is really important to continuing to improve your design as an engineer or an architect.
Yeah. And we tend to just get the negative, like, this isn't going to get done, go
Yeah,
redesign it. We don't get the positives on, hey, this worked really well, to learn, hey, we need to keep doing it that way. Or, sometimes you just
right.
stumble into a good situation.
Yeah, for sure.
Expanding on engineers figuring out their path, what advice do you have for structural engineers that are looking to get into mass timber, gain that type of experience, or trying to pull that into their projects? I know a lot of the structural engineers that I work with, I'm in an AE firm, so I do have structural engineers. A lot of them are excited about mass timber, and it's just getting that projects to come in the door and that initial experience. Do you have any advice for structural engineers looking for that?
Yeah, yeah, definitely. An analogy that I often like to use is, it's, when is the when is the worst time to start saving up for a house down payment? Let's say you're going to buy your first house. When's the worst time to start saving? It's when you already have one under contract, right? Because at that point, it's pretty much too late. You're probably not going to be able to get your mortgage unless you just happen to be sitting on a huge pile of cash. So similarly, in my opinion, when's the worst time to start getting up to speed, or saving money in the bank, if you will, getting up to speed from a knowledge standpoint about mass timber? It's when you have your first mass timber project that comes across your desk, because then, you're supposed to be doing your normal job of designing a structure while also learning this brand new structural building material that you've never worked with before. Um, Not to say that mass timber structural design is incredibly complicated, but it is definitely different. And it's not just the calculations that you're running through, bending and deflection and all that stuff that take different forms. It is that, but it's not just that. It's also understanding how mass timber, number one, behaves differently. Things like it's quite susceptible to vibrations, and other materials may not be. But also understanding how to use it in a most cost efficient manner. Because right now, mass timber is still having a lot of challenges on projects from a cost standpoint. There's a lot of interest in using it. Like you mentioned, some of your engineering colleagues are very interested in using it, but a lot of times those projects don't go forward because mass timber just is too expensive, or it was designed in a manner that maybe didn't use it most efficiently. So not only are you needing to run the calculations, you're also needing to understand the properties of the material such that you can use it very efficiently. So those are some of the areas where it really takes getting sort of a holistic understanding of mass timber. There's definitely some good information out there, in terms of like the actual structural calculation processes to go through. There's been a lot of, good papers written, webinars that are available, videos on YouTube, kind of the whole gamut. It does take somebody being willing to sort of put the pieces together and, understand, this document might be great for vibration, versus that video was a great overview of how to check for, structural efficiencies and span lengths, versus this connections manufacturer has a really good white paper on how to design connections and hangers, those types of things. But I would say understanding the landscape of the manufacturers, both on the product side, so like CLT, glue lam, DLT, the individual wood products, as well as on the connection side, so fasteners and hardware. I think understanding the landscape of who's out there, because it's not a huge pool at this point, and then take a look at their technical literature, understand how that can then start to be implemented, understanding it, so that ultimately what you're doing with all of this is getting yourself ready for the opportunity that is to come along,
Mm-hmm.
right? And that opportunity might come along just by happenstance, because the architect you're working with is trying to get mass timber used on a project. But that opportunity might also come along because you've gone through the process of learning mass timber, and then you can start to demonstrate that knowledge and expertise, which could be a way to attract work to your company, right? So I think it definitely makes a ton of sense to get up to speed now as opposed to waiting. Because, like you said, a lot of people will want to hire an engineer with experience. But if that just means then the same structural engineers continue to do mass timber projects over and over again, it's never going to open the door for new ones to come along. So those new ones really need to get up to speed on the knowledge side.
Yeah, it's always a chicken before an egg thing.
Yeah,
Now, I know you mentioned efficiency with the design. When I think of that, I'm thinking like bay widths, or if there's standard connections that make it more affordable versus, architects creating crazy forms and then saying, all right, let's do it out of mass timber. I'm assuming it's more of a conversation on those efficiency points. Do I have that right? Or can you give me an example?
sure. Yeah, and that's 90% of it for sure. When you look at the total, like if you were to get a bill at the beginning of a mass timber project from the mass timber supplier, and it kind of breaks down, this is how much the material costs, this is how much the connections cost, this is how much the labor costs to install it, all that stuff. The majority, usually, say 50 to 80% or something like that, of the total cost is the material itself, which is really the reverse of most structural products, which is the majority is the
Mm-hmm.
labor to install it. So majority is tied up in the material itself. So minimizing that material to the maximum extent possible is really the biggest way to influence costs. And so to your point about like bay sizes, it really goes hand in hand with understanding, like you talked earlier about the building code, understanding the code requirements for, what is the fire resistance rating. And I usually start there because if you're leaving mass timber exposed and it requires a fire resistance rating, which oftentimes it does, and you can leave it exposed still, but that influences the size of the members, right? Usually if you have sized a floor that's, X thickness and it needs a fire resistance rating, it might need to be a little bit thicker. So starting with the fire resistance rating to understand what does that mean on your member sizes, your beam width and your beam depth and your floor panel thickness, all
Mm-hmm.
those things. So that once you know that, like what's the thinnest it can be while still getting you your fire resistance rating, then you come up with your size, let's say your floor thickness. Then once you know that floor thickness, you can say, okay, based on this floor thickness, its maximum span is whatever, 14 feet, 18 feet, whatever that number is. Then can we lay out column bays that match that spacing or increment, or at least are very close to it? Because it's inefficient to say have a panel that can span 18 feet, but you're only asking it to span 13 feet. Or it's also inefficient to say this panel can go up to 17 feet, but I really need my bays at 18 feet, because then you're going to have to go to a thicker panel, and that's going to drive costs up a lot. So yeah, it's understanding those, the influence that fire design has, first of all, on member sizing, and then what the influence member sizing has on span ranges or span ratings for the members, to really try to dial in and minimize the volume of wood. And then the second place you go typically after that is the connections, detailing the connections. How do these members come together? How can we simplify that process? Simplify and minimize the fabrication work that the mass timber manufacturer has to do, as well as make it a detail that is fast and easy to install on the job site. There's some, say, a beam to column connection. There's different ways to detail that. One method might take 10 minutes to install on site. Another method might take 25 minutes to install on site. Sure, it's not a huge difference, but if you have, 200 of those connections on the job site, that does add up significantly. So the time aspect, the cost and the time aspect of connections and details also plays into that efficiency piece that we talked about.
Yeah. Just like, I think it's good understanding all of the the information you need ahead of time, because a lot of the times the architect will be involved in that early schematic design, sometimes by themselves, and the structural engineer will just be like, hey, this is what we're going to do, and that's how you would do steel and concrete, and that's what it is. But in mass timber, it's got to be a little bit more of a hands-on discussion at the beginning. If the owner wants mass timber or the design wants to go that route, it's all right, we need the structural engineer involved extremely early to see what's possible with that design, to make sure you're not having to, like, I just have nightmares of, okay, now I have to redesign it in CDs because it's way over
Yeah.
budget, just because of bay size lengths not adding up. And you don't usually get that information from the contractor of saying, hey, just reduce the bay a foot and you'll save $1 million or whatever amount. Like, they're just like, nope, you're X number
Yeah.
way over budget. And so sometimes it can be helpful to have that information ahead of time and making sure we don't design ourselves out of having it in our projects.
Right. No, you're absolutely right. Like, column spacing or bay sizing it's a pretty fundamental aspect of a building's design, right? But it's often overlooked because it's something that's hidden in the end condition, right? It's like lay out the building, and then the structural engineer's job often is where can we locate columns, in
Mm-hmm.
walls to avoid being seen, if you will. Versus with mass timber, I mean, first of all, sometimes you want to express the structure, you want to see the structure. So that might be a different thought process. But then also, if you are seeing the structure, not only is it how do you design it, from an efficiency standpoint, like the base sizing we talked about, but it's also because, especially in something like an office building or an institutional where you might see multiple bays just by standing in one spot, it's that much more important to make it kind of look consistent and clean and repeatable, because you're not like in a structural steel building, you might have, different column grids just to hide things within walls. Whereas with mass timber, you wouldn't want this kind of irregular pattern of columns and beams and whatnot, not only from a cost standpoint, but just from a visual, aesthetic standpoint. You want it to look clean and consistent. So it's another reason that the column spacing, location of columns is pretty fundamental on a mass timber building. And like you said, engaging the engineer early to help with those initial decisions is really important.
Yeah. And getting into your own business, Mass Timber Advisors, what services are you providing with that company?
Yeah, I think a lot of it is going to be fluid to try to figure that out along the way, but I can certainly see where a lot of the interest is already and where I would like, a lot of the work to be. And I see that sort of in two different aspects, one of which is a project specific aspect. So, it could be a lot of the things that we've talked about so far, and then those in much more depth where, a developer wants to use mass timber, or at least is interested in using mass timber, but they never have before, or their design team never has before. And they really want somebody to be deeply involved throughout the process and kind of, help hold their hand along the way to help them understand, everything from finding an experienced team to understanding all the nuances of the building code to actually doing the design process with them, engaging other folks that might be able to help throughout the way. So I think that side of it for sure is of interest. And that's something that, I think I'll really enjoy getting back to the project specific side, from my structural consulting days of being involved in a project really from the very start to the very finish. I think then the other aspect of it is more, I guess, what I would call industry or industry related type of work. And what I mean there is, mass timber is a rapidly growing industry. So that means there's new companies getting into the mass timber space all the time. And those could be companies that are making, anything from mass timber products, the wood products, to hardware fastener products, to coatings and sealants, to, fire protecting systems, to erection systems, to software technology, virtual reality platforms. There's a lot that is growing with mass timber and will continue to need to grow along with a growing, market and industry itself. So, working with some of those companies to help them understand what is mass timber here and how is it done? how can they enter the market? What types of technical literature are they going to need to come up with to have rapid approvals, permit approvals on projects? Those types of things, understanding how the code allows mass timber to be used. And, so I think there's a lot there that's an opportunity to be involved with helping advance, the use of mass timber for sure.
Yeah, and it sounded like there's a lot of resources out there, but they're scattered. There's doesn't seem to be like a tried and true like how to or getting everybody up to speed. Everybody's kind of rapidly moving at a quick pace to figure out the system, understand what works, what doesn't work, how to detail it. So I definitely think from the sounds of it that that's a big part.
Yeah, for sure. There's a lot of good resources like through Woodworks, through Think Wood, through FP Innovations is an organization in Canada that has a lot of great resources. And then, like to your point, there have been a lot of other, oftentimes just, consulting companies or architects or other people who have gone through a few projects themselves and have lessons learned. And they're sharing that information. The mass timber is a very, I guess I would say, open or collaborative industry where, it could be just lessons learned from this one project, or it could be like there's a specialty consulting firm called RDH, and they've created a couple of really good guides on the moisture aspects of mass timber. How do you protect it from moisture during construction? How do you detail a building envelope that protects it long term? There's some really good resources out there on acoustics design with mass timber. So yeah, definitely the industry trade organizations have really good information, as well as, just other developers, architects, and engineers who have produced their own literature.
Yeah. What is the recommendation for protecting it during construction?
Well, if you read that document, you'll see that there is a variety of ways to approach it. So I probably can't give you just one, but the variety of approaches, I guess I would say, is maybe at one end of the spectrum, do just about nothing, meaning don't apply additional protecting materials, and kind of just let it be. And then you probably end up with some moisture staining. So you have some sanding or some washing. I'm not saying that is a good approach, but that is at one end of the spectrum. Sort of a middle approach is, sealing sealants or coatings on the top side of the timber. So as it's exposed to rain, especially, and also UV, it protects it in some regard. A lot of jobs are where two panels come together, or like where there's a box out in a panel for a column to go through, doing some type of tape so that you're not getting moisture infiltration between the panels, because oftentimes that then kind of wicks on the underside of the panel and you get some moisture staining there. And then the far end of the spectrum probably is just a full sheet membrane where you're covering the entire top surface of the mass timber. And sometimes that's done on projects like just at the roof level, and it kind of acts as sort of both temporary roof as well as part of the long-term building envelope. For taller projects, they might be doing that like every second or third floor, to act as a means of buffering the moisture infiltration during construction. Of course, it also depends a lot on where the job is, and what the anticipated weather is going to be during construction.
Check out the full discussion from this bite of advice here. If you enjoyed this video, don't forget to hit the subscribe button so you don't miss out on more mentorDINO content.